Dentin sensitivity. Clinicians recognize that dentin is exclusively sensitive to certain stimuli. It is unlikely that this sensitivity results from direct stimulation of nerves in dentin. You can see this in figure 9. This is the figure 9 showing the schematic diagram of essentials of three theories of dentin sensitivity. Picture A will show the classical theory proposed that stimuli applied to dentin caused direct stimulation of nerves in dentin. The classical theory proposed that stimuli applied to the dentin caused direct stimulation of nerves in dentin. And in picture B will say the modified theory. It is the modified picture B is the modified theory proposed that stimuli applied to the odontoblastic process would be transmitted along the odontoblast and passed to the sensory nerves via some sort of synapses, whereas the picture C, that is hydrodynamic theory, proposed that a fluid movement within the tubules transmit peripheral stimuli to highly sensitive pulpal nerves. C. Pulpal nerves. C more accurately represents the here. C more accurately represents the actual length of odontoblastic process relative to the tubules. Nerves are seldom found more than one-third the distance from the pulp to the surface. Picture C will more accurately represent the actual length of the odontoblastic process relative to the tubules. C. Nerves are seldom found more than one-third the distance from the pulp to the surface. As previously stated, nerves cannot be shown in peripheral dentin. Another speculation is that the odontoblastic process may serve as excitable nerve endings that would in turn excite nerve fibers shown to exist in deeper dentin closer to the pulp and closer to the pulp. The experiments of Anderson et al. And Brand-Strom suggest that neither odontoblastic processes nor excitable nerves within the dentin are responsible for dentin sensitivity. Brand-Strom suggests that neither odontoblastic process nor excitable nerves within the dentin are responsible for dentin sensitivity. This led Brand-Strom et al. To propose hydrodynamic theory of dentin sensitivity, which sets forth that fluid movement through the dentinal tubules moving in either direction stimulate sensory nerves in dentin or the pulp. The fluid movement through dentin moving in either direction stimulate sensory nerves in dentin or in the pulp. Stimulates the sensory nerves in the dentin or the pulp. Further support for the hydrodynamic theory came from electron microscopic examination of animal and human dentin, demonstrating that odontoblastic processes seldom, in the sense rarely, extend more than one-third the distance of the dentinal tubules, more than one-third of the distance from the dentinal tubules, that too seldomly. The odontoblastic process seldom extends more than one-third the distance of the dentinal tubules. A work by Lafferty et al. Suggest, suggested that the odontoblastic process may retract from the periphery during extraction. A work by Lafferty et al. Suggested that the process may retract from the periphery during extraction or processing. Obviously, more investigation will be required before any definitive statement can be made regarding the distribution of the process, that is odontoblastic process. The tubules are filled with dentinal fluid that is similar in composition to interstitial fluid. The tubules are filled with dentinal fluid that is similar in composition to interstitial fluid. The hydrodynamic theory satisfies numerous experimental observations, although it cannot yet be regarded as fact. It has provided and will continue to provide a very useful perspective for the design of future experiments. Although it cannot yet be regarded as fact, it has provided and will continue to provide a very useful perspective for the design of future experiments.